As an environmental officer, I can view the light levels of Coventry city centre. As a team, we decided on both a table and graph view. The table view allows the officer to see multiple sensor values. The light level values are selected in this video. Additionally, another user story is covered by this. As an environmental officer, I want to be able to see the current temperatures so that I know when to send out gritting lorries. The graph view allows the individual sensors and visualises the data so that trends and patterns can be seen over time by the environmental officer. Problems tackled here was when it came to the graph view. The API team had architecture issues. To solve this, both the front-end team and the back-end team came together to set a design solution that would allow the charts to be specific to each sensor. As a resident, if I set my location services on the website, then I will be able to see my location on the map. The colours indicate the different levels of pollution in that area, with red meaning high and green meaning safe. Issues found with this user story was the range on the sensors. The key tells the environmental officer what the colours indicate. As you can see, the environmental officer can use the map to view the red hotspots that show areas suffering from high levels of pollution, orange hotspots to show the medium levels, and green hotspots to show low levels of pollution. Problems found from this user story was adding a floating box over the Google Map API. This was something the team wasn't familiar with. A politician can identify the key areas where there is pollution and can raise these issues in upcoming elections to highlight where they are and how they plan to fix the pollution problems. The map indicates through the colours what the pollution levels are in various areas. Problems that were seen were the inexperience the team had with the Google Map API. As you can see, if the home buyer enters a postcode, a marker pops up at that postcode. This shows the pollution around the location of the postcode that has been entered. This can help the home buyer decide if they would like to purchase the house knowing the pollution levels. Problems found from this user story were limited due to this feature having elements that are already seen throughout the application. However, it was at this stage where the branching and testing became difficult as many features were being worked on and team members' Git experience became apparent. A further feature added to the application was the ability for the users to register and log in. Admins and environmental officers had pre-made accounts that would allow them to see different things. If the project had more time, the plan was to create an admin panel which had a range of features to tell of warnings, battery low and weather forecasts. Additionally, it would restrict the public seeing data that was not suitable for them. And finally, for the environmental officer, they would have been able to export data into a CSV file that would allow them to present it to the clients and governing bodies. The obvious issue seen from this was the time constraint and resources being unavailable at the time, therefore this feature could not be fully implemented as wished. The Arduino records the data from 4 sensing units, all relative to pollution levels, light intensity CO2, sound, humidity and temperature. Because the board only had one analog pin, all the outputs for the sensors are inputted into one analog pin. The use of a logical AND circuit and a digital pin for each sensor, the circuit is completed by a toggle, the state of each relative digital pin, allowing the sensors to be individually powered, allowing the analog output of each sensor in turn. The system has the capability of either dynamically or statically setting the GPS location. When the GPS module is attached to the respective TX and RX pins, the GPS location will be set. If the GPS module remains attached, the Arduino's location will be updated every 30 seconds. If not, the latest GPS location is recorded and will be used. When the Arduino has Wi-Fi connection, the data recorded from the Arduino will be formatted into JSON and sent using a web client to the API that transfers the data into a cloud-based SQL server. If a response is not gathered from the API, the data will be stored on the device until a post-web request is accepted. The timings duration of which the Arduino sends the data can also be controlled using a GET request that details the desired frequency of data retrieval.